Hi everyone, so today we're going to be looking at lesson 5, which is modeling linear regression. So what you're going to be doing is you're going to be using technology to help you draw the line of best fit and to create an algebraic model. So do recall, and if you've never heard of this before, linear regression is a process of drawing a line of best fit to make predictions. So you've probably seen it in the past before where you do a scatter plot, which is our points all along the graph, and they don't really make a line up. So what we do is make a line of best fit, which goes right in between the lines, making sure we have the equal number of plots above and below the line. So normally we use graphing calculators in order to draw more accurate lines that we can't usually draw ourselves, but what we are going to do today is we're going to look at this YouTube video. So I want you to click the link after you are done listening to just my little spiel here. And you can watch the YouTube video to help you better understand how to do so. So pause now, watch the YouTube video, and then come back to this video when you're done. Alrighty, so hopefully you finished watching the YouTube video and it was really useful and helpful with how to model linear regression. So a few things to note. We have a correlation coefficient, which is our R, and that is a value anywhere between -1 and 1. So 1 is always going to indicate a strong positive relationship. And if you have a -1, that means it's a strong negative relationship. So kind of think as a positive one is positive, and a negative in front of it is going to just always be negative. And both of them are going to be strong relationships. But if you have 0, that means there's no relationship at all. So when we're looking at these values, there's something called an absolute value. And that absolute value is the correlation coefficient that gives us the relationship strength. So the larger the number, the stronger the relationship. So for example, here we can see that we have -0.75, which is equal to 0.75, which has a stronger relationship than 0.65 because it is a larger number, okay? Because of that, it has a stronger relationship. So we are gonna look at the table below that gives us the amount of times students in a class study for a test versus their test scores. So first, graph the data on the grid. So we're gonna always do our X and Y axes. We have to do time and our test scores. So test scores are going to be out of 90, and then, or sorry, not 90. Our test scores are gonna be out of a percentage, and you can see here, it kind of goes up to 100, obviously, because everything's out of 100. And then we have our time, which is always in hours. And we can have a wide range of hours studied. So what you're gonna do is plot all the data on the grid. And then once you are done, you are going to go to Desmos.com and use the table function. So the table function is going to help you complete the rest of this. Once you do that, you're going to determine the equation of a line of best fit, which is our LOBF, line of best fit, by writing the following formula into Desmos. So you're going to write this formula into Desmos. Once you do that, you're going to round all the values to 1 decimal place. So when you do that, you are able to find the slope, you're able to find the y-intercept. So how do we find the slope? We should know how to find the slope from our past. So we take 2 points anywhere on the line. It also will say on our Desmos website. And then our y-intercept is where it starts at, which is our line of best fit point. So we can see that it starts at 76.4. And then from there, we're going to do our linear regression equation. So we're literally just putting it in formula y equals mx plus b. So our slope is our m, so it's 5.4x. And our y-intercept is always our b, which is 76.4. The correlation coefficient, which is our r, it will say on there is 0.786. And we can determine that this is a positive number. So this is a strong positive relationship. And then is the correlation strong? So when we looked the previous day at our lesson, we are able to determine if we were to put a circle around this entire section here, are they close by to one another? Yes. So therefore, it is a strong correlation. It's not scattered, it's in an upwards trend, and it is close to 1 because we have our correlation coefficient, our R was 0.786. So therefore, it is close to 1. So therefore, it is a strong correlation. Now, next on your information, you're going to fill in the data table using the linear regression model. So if we studied for 0 hours, what is the test score? 1 hour, what is the test score? 2 hours, what is the test score? So using that line of best fit, figure out what is the test score. And then for F and G, you're going to make predictions based off of what we just found out on our linear regression model. So this is very much after following that YouTube video that we just took a look at and using our Desmos website, we're going to work hand in hand with that in order to complete these questions. Once you're done that, I want you to complete the practice questions below. This is the exact same thing that we just did, but we're using the Desmos website again. So please do take a look at this now on your own with the Desmos website. The Desmos website is fantastic. It is always very, very useful. So